talk about what I call the Python project checklist. That is kind of the tools and things that you want to pay attention to when working, or that you want to make sure that you have available before you start working on the project. The first thing is a Python interpreter, which is obvious to run the code. Then I suggest you have a nice text editor. And here, full disclosure, all of these points are up for controversy, and like people will defend Emacs and Vim to death, and the same thing will happen to other editors. So I'm not going to go into the politics of coding and tell you which editor you should be using. So I'm just going to say, have a nice text editor. And for all of these instances, I will show you my setup. So the ones that I use. And if that's useful for you, then that's great. So same thing for the virtual environment solution. And I will talk briefly about what the virtual environment is in case you're not familiar. Version control, dependencies, how you handle dependencies in your code, documentation, tests. We are going to focus only on unit tests, so which is kind of the most popular way of like deploying tests in, at least in Python. And two optional, the ones in brackets are optional, but I think that they're very important. I don't like to start a project without these two, and it's a linter and a formatter of the code. Okay, so I'll get through each of them, and if one of these like categories is not clear, I will explain it over the course. So the first thing is a Python interpreter. And just so you know, there are multiple Python interpreters. The most popular ones that I know of are CPython, which is the official one, the one that you will download, for example, in the Python website. And there's PyPy, which is, if you go and like make a query, you will see all sorts of arguments for defending PyPy, saying that it's faster than the, sorry, I'm gonna shut down the Slack, it's distracting. So getting it out of the way. So all sorts of basically reasons why you should use PyPy. I'm not going to get into those kind of politics. I always use just the official one, okay? So just so that you know that are multiple implementations of a Python interpreter. The official one is the one that you find in python.org. That's it. So that's one thing that you want to have available. The next thing is a text editor.
I personally,
yeah, sure.
Because Python keeps getting updated like really quickly, is there a set version we're going to use, or should we just update it as it comes along?
Right. So yes, good question. I think we mostly want to cover as much of the Python versions that are not end of life. So for example, 3.5, I think it's the end of life for many projects, and 2. Anything, it's end of life. So we don't want any Python 2 code bases. That we have some that like are legacy code bases, and we have to slowly migrate into Python 3, but we don't want anything new that is done in Python 2. And for each of those like branches of Python 3, like 3.7 or 8 or 9, we usually try to support them all. And that's maybe a question about unit testing and other things that you can do. So for example, you can set up your environment in GitHub Actions or when you do your unit test so that it runs on different Python versions. And technically your code should work, right? And if it's not supported, for example, you have a feature that was introduced in 2.9, then you should specify that in your project and say this is compatible with 3.9 plus, which I don't think should be the case because 3.9 is still not very popular yet. There are many projects that are behind. So let's say 3.6 up to the most recent one. Yeah, I don't know if that makes sense, but cool. So text editor, I use Visual Studio Code. I like 2 years ago, I went through the entire journey quest of like using Atom for a while, then using Sublime, and we have licenses for Sublime, for example, like 20 licenses. my conclusion is that Visual Studio Code is the best community. Everything is the best. So if you just want to trust me, go for that. And I see like thumbs up, so I'm happy to see that others use it, are using that too. Virtual environment, same thing. Like there are multiple ways in which people deploy their. Okay, so the concept of a virtual environment, in case you're not familiar. Uh, Nowadays, we want to isolate everything. Okay, so that's the concept of virtual machines, of virtual environments, containers, always around the same idea of isolating the project as much as possible so that you have control over every aspect of it, including, for example, the hardware or the system libraries or everything else that might introduce bugs that you didn't want to, that you were not expecting to introduce, or that were not introduced with your code base, but with the environment. So virtual environments are just a way to ensure that within Python, so you always have a global interpreter of Python, right? That's the one in your system, in your operating system. And if you, for example, install something, let's say that you install a library for working with Volpiano, that's going to be global. It's going to be for the entire operating system. But if you're working with a specific version of that Volpiano library in some project, then you don't want that to be dependent of that Volpiano version being available in your entire system or anything else. So virtual environments is just a fancy way of saying that you have a Python interpreter. So you have the global one, you take it and you copy it to a folder that is just constrained to that specific project, and you're not touching anything else from the operating system, like global environment. And whatever you install there, like packages or anything else, it's gonna live within that interpreter that you copied to that project. So anything should be reproducible in terms of, if I install, an XML library version 3.1, and that's the one that it needs to work, this project needs that library to work, then you can inform that all of those versions in your virtual environment, and then it should be completely reproducible no matter whether you move to a different machine or anything else. Of course, this doesn't capture the environment of the hardware itself, so that you will need one more layer of abstraction for that, like for example, a virtual machine or something like that. But in general, virtual environments will ensure that the Python project works across different environments of Python, or different computers, let's say. Someone else clones your project and it will work if they have a virtual environment and you set all the requirements that it needs. The most popular one, and the one that I use, is venv, which is the kind of the official one by Python. People use some other virtual environments. So for example, there's a popular distribution of Python called Anaconda that is very popular among data science and machine learning. It has its own ways of dealing with virtual environments. There's also, what other ones? The PyEnv, that's another very popular one that people like. I just used venv because that's the visual one. And in my experience, it always becomes difficult to catch up with software that, or to migrate software that gets obsolete, and the 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 probability of a software, of a non-official software being obsolete at some point or stop being maintained is higher than the probability of an official piece of software. So I always go with the official one, even if it's not amazing, but that's my personal choice. So I would choose venv for creating virtual environments. I will create the virtual environment and project that we will work on, so you will see how that's done, like creating the virtual environment. So that's another aspect to worry about. The next thing is version control. And of course, we talked about Git and how it works, GitHub to host remote repositories of Git. And this is the only aspect in which I say that you don't really have a choice. We work with GitHub, it's constrained to GitHub, to Git. So there are other options like Perforce or SVN. There's really not an option because everything we do is based on Git. So that's me saying Git, no choice. But it's great. I think it's it's probably the best uh, version control solution out there, even if it's not super intuitive. I don't know, but that's a fixed, let's say, item in the checklist.
Would you recommend something like GitHub Desktop that makes it a bit more streamlined, I guess, or just terminal stuff?
Yes, I do recommend something like visual, especially if you were working on a complex project that you have multiple branches. Something that I've seen is that visualizing the branches as a graph is much, much more intuitive than just watching the logs on the console. So people like Git Kraken, for example. I think it requires a license, but if you're a student, you can get a free student license. There are tons of like Git visualization tools. GitHub Desktop was really bad at the beginning, but now I think it's kind of okay.
I think it's pretty good, but
Yeah.
Yeah, I was gonna say I used GitHub Desktop before and
Okay.
wasn't a huge fan, but
Yeah, I mean it's getting much better. Like I used it maybe 2 weeks ago, and the thing is they don't distribute the GitHub Desktop for Linux, so that's why I'm not like really up to date into how it works. But I remember I was on the beta of GitHub Desktop. It was horrible. Then, like a couple weeks ago, I tried and it was much better. So I think it's just getting a lot of support from the community and it's getting much better. So yeah, I do recommend it. The only instance where I don't recommend using a tool like that is if you're going to be a developer, like working on a serious project and you don't have an understanding of Git, those interfaces will be like a shortcut that you will just give you the tools to do quick operations, but you don't understand what you're doing on the backend. And I've seen people doing that, like they're just clicking buttons on the interface, no idea what they're doing behind the scenes. And if you're just a user of the tool, I think that's fine. You don't need to know what's going on. But if you're going to be like working on projects that you know are going to grow and become more complex, I think you should be very familiar with the operations, like what the merge is and conflicts and all of that. And if you are just like proficient on all of those things, then the interface is going to be a great relief in terms of time and just visualizing stuff and doing operations quicker. So that's kind of my point of view on graphic user interfaces for version control. Dependencies. Yeah, this is another one that, so people nowadays, the cool thing, I think it's Python poetry. That's it's a very like that's how you handle dependencies and things on your code. I don't use it. I use just a requirements.txt file. That is the regular thing that you do with pip and where is it? Well, I put the link on the slides. By the way, let me put these slides. I'll put them right after when we go to the break. I'll put them on the Slack so that you have them available. But yeah, just that is requirements.txt is a text file, plain text file with just package names and versions. That's it. But I think even if you have that, that's very useful. And I suffer a lot when people don't have a requirements.txt, especially in projects that involve some sort of machine learning or anything like that. It's really complicated to replicate the environment, and this having that information helps you a lot. So I just recommend having one of those, like requirement.txt, and it's super easy to generate. Just basically run one command, and the output goes to a txt file. You commit that to the version control software, and that's it. Okay. Doc strings is a very common thing across Python. It's not only for, so there's a definition if you want to read the discussion about how doc strings are defined in Python. The most important thing about doc strings, in my opinion, is that you can use them to generate documentation automatically. And I don't think there is a consensus. I don't think there is the official tool for generating documentation. There are lots of flavors. Some people use Markdown. There are like multiple notations for how a doc string should be how the syntax of the docstring should be like employed. And there's the Google syntax, there's the NumPy syntax, and so on. So here I would just say, try to find the one that you like the best. If you are going to generate automatic documentation, which is encouraged in a large project, I personally have used pdoc3. It's probably the easiest one in terms of like you have a doc string in your code. You will see examples of a doc string, by the way. So if you haven't seen it, I'll show you some examples. And basically you just run a command and it will generate some HTML documentation based on your doc string. So that's uh, something that I recommend. I have to admit that I don't generate documentation very often. I do other things that I should, like tests and so on, but documentation is one that I'm kind of like lazy about. So I'm not super experienced. I don't remember exactly how you will get fancy, nice documentation. It requires time and effort to get something meaningful out of the doc strings, but it's possible, and you don't have to spend a lot of time and writing some doc strings and generating documentation automatically for your project. So that's basically something that you should be aware that there's the opportunity to just generate stuff automatically from your uh, comments. It's basically just comments on the code. Uh, and then we have tests. Tests are something that I do recommend, like doing anytime you start a project, and I think people should pay more attention to writing tests. The reason why is mostly because you can automate them, okay? So that's one of the things that we'll see with GitHub Actions, that you can automate the, the GitHub interface so that, for example, every time that I push a commit, it will run all the unit tests. And here comes the part where we were talking about different Python versions. So I could just set the environment so that it runs tests on Python 3.7, 3.8, 3.9. And it will do that automatically every time I push a commit. And also it will inform me, like send me an email if one of those versions crashed or something happened. So it's a lot of feedback that you get for free. Just like you don't have to spend a lot of effort in writing one unit test, and then just it becomes sort of a habit to do it. And there's something about unit tests that when you write them and then you push them and automate them, you start feeling like your code is just getting automatically better, because it's like a safeguard, that it's there. If you modify something, let's say that you replace a function with another implementation, I will be scared of that change if my code was complicated and that function is used in different places. But if I have unit tests and I know that I'm testing that specific portion and just making sure that everything else doesn't break, then I will not spend as much time. Just change the implementation. If it passes the unit test, then it's good to go. Maybe there's a bug that you haven't found, but that's a unit test that you haven't written, and you will find about that later and like have to write a unit test. So that's something that I do try to implement in every project. Not always possible, or not, there's always like fires to put up and unit tests get compromised. So the time spent for unit tests gets compromised, but I do recommend that everyone does this. The two optional things that I was talking in brackets, one of them, the linter. So linters are just basically static analyzers. I don't know if that concept makes sense or you heard about it, but let's say that you were working on a language like C. Something that people will do is try to run some sort of compiler, but a little bit more pedantic than a compiler, where it will, for example, match that if you're, what would be a good example? Yeah, so things like the length of your lists or arrays or anything like that coincides with the lengths that you're using within the function. And generally the compiler wouldn't complain about that. That's a logical error that you will find once you actually run the code or something. But with the static analyzer, you will find those kind of problems. And the same thing goes with Python. So for example, it checks uh, the length of your lines of code and that you're using the variables. If you're not using a variable, then maybe it will show a warning and say, hey, you're defining this variable here, but it's not used anywhere, right? It's technically not an error, but it's still informing you about something on your code that looks like suspicious or weird. So the way that I use linters is that I automate them in my text editor, for example, in Visual Studio Code. And there are other things that I do on top. For example, removing trailing white space from your line. So for example, let's say that you finish a line and then it has 4 extra spaces. I automate certain things. So for example, remove all of the trailing white space and run the linter every time that I save the file. And that helps a lot. One of the things that it helps you with is reducing the number of changes in your commits. So for example, if you have trailing white space but nothing on the line of code change, you don't want that to be committed to the version control, right? So this just gets rid of all of that and just basically cleans the code, and then you can push it to the repo. So that's
Sorry, go ahead.
yeah. Go ahead.
So on like VS Code, for example, before committing, we should just run like the auto formatter for like auto pep 8 and then just push everything, right?
Yes, and you can also automate it if you want to have it on both ends. You can also automate it on GitHub Actions, for example. So that, and that's useful when someone external to you is, let's say that you have a very disciplined, uh, development workflow, but you're collaborating with someone else. You want to make sure that their code has also the same standards as yours in that sense. So it's useful to detect that in pull requests, for example. So it will run the linter, and if it doesn't pass, then it will automatically reject, or not reject, but block the merge of the pull request. And then the person submits another commit, and until everything like passes all the tests, then you can merge. And you don't have to do anything. Like if you're the developer, the maintainer of that repo, those tools will do that for you. So yeah, I'll show you how I set up the linter. I use Flake 8, by the way. That's the one that I like. It's the most pedantic that I found, and I usually like the most pedantic because basically it enforces, or it makes me write code that will pass PEP 8 validation and so on. Okay, and formatters. That's something that I adopted recently. And it's completely optional, but I've seen more and more people adopting this. And a formatter is essentially a tool that takes your code and creates a graph of what that code represents in instructions, and it just replaces it with a unified formatting. So for example, let's say that you typical example in C will be, and just so much time wasted in discussing all of this by so many people, like whether you start the curly bracket braces on the at the end of the line or at the beginning of the next line. People have arguments about that, and what the formatter does is just like basically saying, let's not care about that. I'll just put all of them at the end of the line. And what that helps you with is, again, reducing the amount or the changes on the diff of your version control changes, right? So if all the formatting is normalized, it's all the same, then you would expect to have less and less changes when you submit code. And also, in Python, it's particularly helpful for just copy pasting lists or something like that from the from the console or whatever place you want. and it will just automatically format that in the best possible way. Same thing for functions, parameters. It saves you a lot of time. I really like using formatters nowadays. You can also automate them and have them. So for example, turning the formatter as into a test. And whenever someone makes a pull request to your repository, they have to pass the formatting of black, for example. And if it doesn't pass, then it requires them to do that before merging the request. So very useful. I'm adopting them like mostly to any project that I'm using nowadays. Uh, didn't want to get in too much into the politics of coding, but I put a few of the, if I have to like compress the things that I think about when I'm writing code, or the philosophy, let's say. Something that I notice is that the more I write code, the less I want to write code. So I'm less verbose. I want to write less and less. The reason is because it's very expensive to maintain, and I learned that from especially from working with Michael Cuthbert, who's developing a library for music theory and computational musicology called Music 21, in case you have heard about it. And it's a really large code base at this point. And basically what he says is that maintaining a feature or anything is very expensive because people commit code and then they don't maintain it. And that becomes a problem because you have a lot of code and you don't know what it does. No one really knows because the person who did it went away and so on. So that's something that I've seen and experienced myself, that it's expensive to maintain. Uh, I've been also writing papers since I started grad school. And something that I did at the beginning is I started writing something and realized, okay, maybe I'll use this fragment for, the conclusions of the paper. And I have a lot of like little drafts of text thinking that I will be using in the future. And I never did. Like I almost always, 2 minutes before the deadline of submitting the paper or the project or whatever, I remove all those commented pieces of text that I thought that I would be using. And I think the same thing happens with code. Like you write something thinking that you will be using it in the future, it almost never happens. So that kind of goes with the same idea of the less amount of code, the least amount of code possible is the best solution. Um, Hack until it works, then go back and refactorize the hack. Yeah, because most of the times we work with deadlines and we have to deliver something by Friday at 3 p.m. And of course, the code quality is not going to be the best. So something that I like to do is just get the thing working. And then as you do that, you get an idea of what you need to change to make it better. So right after it's working, then just go back and like refactorize that last portion that you did. I find that to be a kind of a useful workflow. Um, this point is about the same thing I was talking about with linters. Make it like a non-optional part of your workflow so that it's automated. You have a robot sending you emails, annoying emails every time that it doesn't pass your validation, and that helps you like keep a certain quality, right, to your code. And one thing that people don't like, it's enforced in PEP 8. So it's actually part of PEP 8 in Python, the 80 character limit. And something that I found is the shorter the lines of code, the most readable they become. And I just like having that limit for that reason, not because and people argue about, this was imposed by punch cards of the 70s and so on. So that's, yeah, I like 80 character limits in my lines of code for, and I think it's useful. It's useful as a human. Maybe your Gestalt machine inside your brain parses things quicker and better. And a lot of the things that I just putting here have a like sort of, I wouldn't say they all can be summarized in this, but it helps to know all of these like shortcuts, and people call this idiomatic writing, like idiomatic programming, in this case idiomatic Python. And it's just like, think of it as having formulas. Whenever you have some certain pattern, like you're comparing two quantities here, uh, two variables to a single variable, you could do this, but there's a syntax that is supported by Python that is shorter. Usually something that a pattern that you will see with this idiomatic Python templates is that they are shorter than the other version and usually more readable. So I encourage you, this is a Medium post, but actually it comes from a book called Writing Idiomatic Python that someone wrote. And yeah, I think many of these, if you are in doubt when I'm writing code specifically to Python, I will encourage you to see if you can find one of the templates or the formulas here for idiomatic writing. Yeah, it's very useful to just follow these patterns, and when you start writing like this, your code becomes easier to read for other Python developers. That's what I can say about this. Okay, so please go and look into that, or I'll refer you to that every time there's anything. Maybe in the examples that we will see today, there will be some like examples of these kind of patterns. So hopefully they all show up in this post or the book if you want to read the book. So that's what I have in terms of Python checklist and what to worry about when starting a project. I don't know if you have any questions about this, comments. No? Okay. So I think let's go to, let me see, how much time do we have before the break? So break is at 12:15. Okay, cool. So let's go to this repo, which is empty, but we will like write stuff today to make it not empty. This is the link. I'll put it on the chat. And if you can clone it, that'll be great, and follow through what we're going to do. If you just want to watch, that's fine. I think I'll be doing everything that needs to be pushed into the repo, so it's possible to just watch. Yeah, so I was thinking about what the repo is called Volt Piano Toys, because it's just like toy functions that we will implement, nothing really meaningful or useful, but they will be good to exemplify or demonstrate the GitHub actions. And yeah, so that's the purpose. And we're going to do 3 functions. So one function is obtaining a list of Volpiano strings from Cantus. And we'll do that through one of the CSV files that that are available on the Cantus database. If you remember from the Cantus Ultimus, there was like a CSV, and inside that CSV, you have strings for the lyrics and strings for the Volpiano. Basically, the first function is just extracting the strings of Volpiano. So that's one function. The other function is to validate, and it's a very silly validation process, but basically just making sure that whatever string we're seeing or sending to that function returns true if it's a valid Volpiano, or false if it's not. And the last function will be comparing two Volpiano strings, and it's gonna tell us like the score from 0 to 1, depending on how close they are, like in terms of match. And we will do this with a very simple approach like string comparison, string similarity metrics that are available in Python. So nothing fancy that actually looks at the music or anything like that. It's just comparing the raw strings. Okay, so first thing I will do is I'll put some issues here representing the functions that we want to implement. So let's say the first one is obtain Volpiano strings from a campus CSV export. Include the option to
For Python stuff, do we usually set up the requirements .txt in the GitHub repo, or do we keep it locally?
No, we want to version control that. Yeah,
Oh.
to commit to the version control history. We'll do that once we install the stuff that we need. So maybe it's the last step before, like, yeah, like after implementation, if you needed a special library, for example, then you install that in your virtual environment, and you basically just dump everything that is in the virtual environment into the requirements.txt. That's the process that we'll follow. So I added the first issue, obtain Volt piano strings from a Cantu CSV export, include the option to obtain only piano Volt strings with the maximum length. That's just an optional parameter of the function. Another one will be validate Volt piano string. Return true or false, depending on whether let's say valid Volpiano. And the third one is going to be compare. So it's inclusive. It can return 1, 0, or it can return 1 or anything in between. These are just very simple issues that I put there. Okay, so now the first thing that we want to do is get the repository. I already did that. Just clone. I hope that's not a problem. Same thing that we were looking into the other day, origin. So I get that automatically when I do clone. I'm basically getting a reference to where I got it from. And it should be this repository of, and I actually made a mistake here because I cloned it with HTTPS. Let me go back. Yeah, I don't think I can explain this, but two-factor authentication in GitHub disables HTTPS push, okay? So you have to use SSH keys at that point, or like API keys that you generate from GitHub. It's a complicated thing to discuss, but basically the bottom line is that I need to clone, when I clone this, and if I'm planning to push and I have two-factor authentication, I have to do it through SSH. So
Should we
you have
set that up as well?
Sorry?
Should we set that up as well? Because I just did HTTPS.
If you're planning to push and you have a two-factor authentication set up in GitHub, yes, you will need to.
Okay.
Yes. So
sorry, can I ask a question? Do we
Yes.
have to do that like when we clone it for the first time, or do we change it after the fact, or how does that?
Right. So you do it the first time. So the thing is, when you clone, I have these two options. When I clone, this is going to be written into my GitHub repo locally. So yeah, just once, basically.
But like if I have a repo now that I cloned with HTTPS and now I'm on 2FA, should I re-clone the repo or should I change it?
You can reclone the repo using this. Another option will be to add a different remote that communicates with the SSH.
Okay.
Yeah,
Thank you.
that's another option. Yes. So I'll just do git clone and the URL of the repo in SSH. I have my SSH key. That's why it communicates, authenticates, and all of that. And I get it. So now I'm in Volpiano Toys. And here it is. It has a license and a README file. Nothing else but that. And a git ignore. Git ignore is just a special file where you can define certain files that you want to ignore. One of typical one in Python is the Python compiled versions. So you run Python, it does some operations like compiling and optimizing the code so that it runs faster. You don't want to submit that to your version control. You don't care about that. That's an auto-generated file that's useful only when you run it locally, okay? So that's the kind of thing that you will want to ignore, and that's the reason for having this file here. And they have, if you wonder about all of these, like I didn't write all of these entries, they are just templates of git ignores. So when you add a git ignore file in GitHub, it will ask you like, do you have a certain language in mind? And if I say Python, it will suggest all of this. And it's just like, let's take all of this like git ignore template. You can see all of that if you create a repo from scratch. It will ask you to make a git ignore with the initial commit, and you will see the templates and everything. So I already created the repo, so I cannot show you that, but it's really easy. Okay, so now that I have everything there, I'll just show you that it's cloned, it's there, and what I'm going to do is I'm going to open it with Visual Studio Code. Code is the binary name in the console for the Visual Studio Code editor. So if you just do code dot, it's the current directory. It's gonna open the Visual Studio Code editor with that within that folder, and it's here, Volpiano Toys. It has a git ignore, a license, and the README. That's everything it has. So the first thing that we want to do is to create to obtain the Volpiano strings from the Cantus database, right? And for that, so there are multiple ways in which you can like sketch your code in Python. So some people write to start. By the way I'm going to organize the repo is I'm just going to have one source code file, which is going to be called volpiano.py. That's going to be the main one. And I'm going to have another one called test_volpiano.py. And it's going to be the file that has all the unit tests for the functions. So I am expecting to have one function or three functions in the volpiano.py and one unit test per function on the Volpiano test Volpiano. In fact, I can just start like sketching that. So I have a volpiano.py. I'll have a function called obtain, and it basically
Sorry,
gets...
Nestor, can you make this a little bigger?
Yes.
It's hard to see on small screen. Thank you.
Yes, no problem. So this is how you define functions in Python. And for now, it doesn't have any implementation. Then there's validate. That's the other issue that we put. And there is compare. And for now, we'll just not implement them. And I'll create a test, volpiano.py. And it will have, we will use unit test for... It's a module, like a library in Python, standard library for unit tests called unit test. It's on the slides that I'm sharing soon. And basically, this is a template of how you write a unit test. You import the library, and then you create a class for each of the things that you will be testing. So in this case, it's you're free to organize it whatever way you want. So the way that I'm going to organize it is I have a single class called Volpiano, and each of the tests, I will have 3 tests, and one of the tests is going to validate or make a test for each of the functions, right? So if I have 3 functions in Volpiano, I expect to have something like import unit test and class test Volpiano unit test the test case. This is just a template. If you want to use unit test, this all looks the same regardless of the project. And then I have 3 functions: test, obtain, this is a class, so it has to have the self, then def test validate class, and def test compare self class. So this is my basic template of how the project is going to look. I have a single source code file, and I have an accompanying test file that will just basically operate over each of the functions that I know that I will implement. Okay, so I think at this point we can start filling out the content of the functions. So obtain, the way I was thinking about it when I was drafting this project is we have Cantus. Of course, we could create like fake Volpiano strings, but I think it's better if we just take like real ones. So let's go with my old friend Paris 15.81, and this is the entry in Cantus for this manuscript. And if you remember, in this CSV export, there is metadata about all the chants, including the all the Volpiano strings. So let me open that.
Sorry, was the Python environment, do we assume it's set up before we start working?
Yes, sorry that I forgot about that. Yes, let's set up the Python environment. Yes, good. So, okay, I have the repo, and it has these files. I haven't imported anything yet, so it's a good time to do the part of the virtual environment. So the way that you do this is, I have the Python 3. I'm working on Linux, and by default, you already have a Python 3 interpreter in Linux. I think it's the same for Mac OS. So you all have this. If you do Python, it's going to be a Python 2 interpreter. Where is it? Python version, is it? Yeah. So if I run Python version, it's going to say it's 2.7. If I run Python 3, it's going to be whatever Python 3 version I have, like 3.8.5. Okay. So what I want to do is I want to run Python 3. -m means that I'm going to run a Python module, and some of the modules in Python have like, think of them as binaries, like programs, let's say, and vend is one of them. So when I do this, it's going to create a virtual environment, and a virtual environment is just a copy of this Python global interpreter into a version that it's going to be lying here in this repository. Okay. And that I have to give it a name to the folder where it's going to be contained. You can choose any name, so you can call it like Volpiano environment if you want, whatever you want, but I usually call them .env. The reason why I do that is because it's like taking automatically by Visual Studio Code, and it basically, when it sees that I have a virtual environment within a folder called .env, it automatically logs into that virtual environment, and everything that it runs in my code, it's going to be run within the virtual environment. So I'm going to create that. And if you look at the folder, it's going to be there. Okay. And if we look at the contents of the virtual environment, I think there's going to be a lot of stuff. But the main thing that you want to observe is that there's a bin, which stands for binary. And within that, there's a pip, which is the Python package manager, and Python. Okay. And these two are essentially just like your local Python interpreter and Python package manager that we will use through the project. So the way that you work within a virtual environment is that you activate it. And when you use venv, you use a command called source. This source command is just basically bash that will import external variables and environment variables and things like that from a script. So I'm basically reading a bash script. Okay, that makes sense. And it's canonical. It's always the same. You go to the folder where your virtual environment is, then bin, then activate, and you run those lines of code, and it will show like the name of your virtual environment on the left if you did it correctly. And what that means is that you're basically running on a local Python interpreter. So for example, by the way, if you want to deactivate it, you just do deactivate, and it will take you to the global scope of Python. Something that I can do to show you is if I do pip3 freeze, that's the command we use to generate the requirements.txt. And here I am in my global environment. So I'm looking at the global Python packages that I have installed in my operating system. It's going to be a lot, right? It has, because that includes everything that I've installed for Python in my computer, like TensorFlow or Torch Vision and all of that. But if I log into my virtual environment, which is source.end bin activate, and I do the same thing, it has nothing because it's just a clean Python environment that has no packages or libraries and just a fresh start, let's say. And at this point, I'm not sure if Visual Studio is going to capture no, it didn't. Let me close the Visual Studio Code and run it again. And it will hopefully detect my virtual environment automatically. And yeah, you see this message on the bottom. It says, we found the Python environment in this workspace. That's the .env. And that's the nice thing about having a text editor like Visual Studio Code that has tons of tools. Oh no, I didn't activate it. I don't know how to get that message again. Oh, it is. So I just want to say, do you want to select to start up with the features in the Python extension? Sure. And basically, it's gonna, wait. Yeah, here it is. So you will see the interpreter that I'm using on the bottom. And it says it's a Python 3.8.5 that is a virtual environment. So now I am running under the virtual environment of that I created. So I don't have TensorFlow. Like if I want to import TensorFlow, even though it is in my machine on my global Python, it won't find it because I'm running under the local Python interpreter. So that's the use of having a virtual environment, and whatever libraries we will actually import here, those will be part of the requirements.txt, and I'll be able to export them very easily thanks to the virtual environment, essentially. Okay, so we have 2 minutes left. So I think that's just the basic template. Is it clear, like what functions we're going to implement? So we use 1.3, we got one unit test for each of them. You can read, like, unfortunately, it's not a long time that we have available. So I'm not covering, the documentation of unit test, but you can go through this. It's on the slides. First thing I'm going to do is put the slides on Slack so that you have them. And the same thing goes for virtual environments and everything else. They all have like documentation that we cannot cover entirely, but general idea is there. Okay, so when we go back from the break, we're basically going to fill these functions and have them like committed to the code, and then make those tests that we implement for them to be run automatically. And that's going to be the rest of the tutorial. So I think it's a good time to break. Yes, 12:14. Yeah. So see you in 1 hour. Is it? Cool.
I just have a quick question. Everyone else can go if they want to. It's just
No,
about
it's
Git.
okay.
I was trying to, for some reason, like using the SSH, I'm unable to pull, like to clone the files. I keep getting oh wait, where is it now? Oh yeah, it keeps just saying permission denied, and it could not read from the remote repository.
Oh, okay.
Maybe it's how I set up the key. I don't know. It's
Okay, yeah, we probably need to check that because the repository is public. So
yeah.
you don't even need authentication in GitHub to clone it if you use HTTPS. But if you want to push back to the repository and you have two-factor authentication, that you will need to log in. And that login part is where we use the SSH.
Okay.
But yeah, it might be something on your settings for GitHub. We can sort that out. Like, in fact,
Could you just clone it with like HTTP?
That worked when I tried it. It functioned. I figured, because I have two-factor authentication, so I figured if I want to push at some point while actually doing the project, I should figure it out now. So
right. Okay, so how about this? We are, let's say, on the break, but if you want to share the screen and show me, I'm happy to look into it, or after the tutorial.
We could do it later. I mean, I'm sure everyone wants to have a little break, go eat lunch. So
Right.
all right, and maybe I'll figure it out during my lunch break at some point. And it'll save time.
Yeah, if you want to like ask or share something on Slack, I'm also be paying attention to it.
Okay. I guess I'll see you guys when we're back.
Yes. Okay. Thank you. See
Bye.
you soon. Bye. Yes. I was recording locally for the first part, and I resumed it. I don't know if that's gonna like create all sorts of problems, but let's hope not. Okay. So I was saying about, yeah. So I will usually sketch stuff in my Python interpreter, in my interactive Python interpreter. I use Python 3. And for example, do things like create a list here and like templates of or drafts of a function. And then when it works, I just copy it to the source code file. But I think it's gonna be difficult to read. So I was thinking about using a Jupyter notebook just to sketch stuff here that is easier to see on the Zoom screen sharing. But all of the things that I'm going to be doing here are not going to be committed. It's just basically a playground for sketching code. That's the important thing. Okay.
So I also sent this to the Slack, but on Mac, unfortunately, dealing with Python versions is the hardest thing in the universe, apparently, because Mac OS has Python 2.7 and 3.8 like as defaults,
Right.
and they're in a different area. And then you install Homebrew, and that adds another thing, but you can't change the system links because there are different defaults. So if anyone wants to use Python 3.9 and onwards, they should update it using Homebrew. So that's just like brew upgrade Python 3.
Right.
and that'll give you Python 3.9.5 or whatever. And then in your terminal, you should write 3.9, like Python 3.9 instead of Python 3, if you want to use it for virtual environment stuff. I don't know why it's so difficult for them to just purge it or set defaults, but it is. So it is what it is.
I think it will change once 3.9 becomes the new default, and at some point that will happen. Like, it's normal. Like, people oftentimes, like in Linux, for example, it happens that the Arch Linux community always have the latest bleeding edge software, and everyone else is lagging behind. So mm, um, my approach to that is usually that let me close the Slack for during the session. Sorry. And yeah, so basically whatever seems to be the most supported version. For example, now if I look at a lot of projects in Python, they all work with 3.8. So that seems to be, my recommendation will be work with 3.8 for the time being. And that's your like global interpreter in macOS, right?
Yeah, let me check which version it is, because I may have updated it before, but it really is hard to understand. I think it's 3.8.2 is the Mac OS default, or it is at least on my end if I managed to upgrade it before. If anyone else could confirm. If you go to VS Code and click on Python interpreter, you should be able to see them.
Yes. So I'm using Python 3.8.5.
All right, see your version.
3.8.2 is default on mine,
Okay, yeah.
but I'm currently using 3.9 point something.
Oh, then let me ask you, when you want to call the 3.9 version, do you also have to type in Python 3.9, or when you type in like which Python 3 on your terminal, do you get
No, if I do Python 3 version, I get 3.9.2.
How? All right,
But I have everything set up through Homebrew. I'm not sure.
Yeah, it's a nightmare. Like I've been in that situation where you have a different version. By the way, Python 3 is just an alias, I think. So it's really just pointing to some other binary.
You can check that in your bash RC file. I'm not sure what it is on the M1s. I haven't done that on my M1 yet, but
see, I even like hard broke the links and then forced the links for 3.9 onto Python 3. Still didn't work. Still showed me 3.8. Even though they have the same locations, like 3.9 user local bin Python, 3.8 user local bin Python 3.8. But 2.7's in the same location as 3.9, but it calls 3.8. So it's this whole thing of like, yeah, you know.
Yes. And that's one of the reasons why people like PyEnv, which is managing Python environments for you.
I use virtually env instead of venv or venv or whatever.
Okay. Virtual.
And I don't have any issues with that one. I think that one's from who manages that.
It's actually fine once you set up the virtual environment, because like, VS Code automatically gets that interpreter, right? But until you do that, it's a bit confusing. But once you get it set up, it's fine.
You know? Yeah. Okay, so I think we should maybe get started. Is it the size correct? Okay, so in order to have some time for the discussion of talking about the solutions and so on, I already pushed the code that we will be, I found the mystery of the public key. It put it on my in my current directory.
Yeah, I just figured out. I was looking through my where it was, like all my desktop and everything, and it just saved in the most random spot, but it worked. So hopefully it'll create a functional key.
Okay, so that solves the mystery of where the public key went. Okay, so we were talking about 3 functions. 1, obtain both piano strings. 2, validate that is a both piano string, whatever way you want to validate it. And 3, compare two Volpiano strings and give a score between 0 and 1, depending on how close they are, how similar they are. So we could fake Volpiano strings, but I actually think it's better if we work with actual data. This is a CSV export of one manuscript, my old friend 15181. I'm going to put it on the chat just so that you have access to the link. And basically, this is a CSV file. If you haven't worked with the CSV file, it stands for comma separated value. It's just a fancy way of saying that you have lines or rows, and each of the columns is separated by a column, by a comma, okay? So if you look at the, I downloaded that one, that particular one we're going to use, and it looks like this on my editor. I have an extension in VS Code, in Visual Studio Code, that like adds colors to each column so that it's easier to read. But so if you open that in Visual Studio Code and you don't have the plugin, you will just see like plain text with commas. But if you have the extension, you will see like this, right? And another way that you can work, because CSV data is very common, like in a lot of different places. Another very typical way that you can just see it is put it on a Google spreadsheet or Excel. And oftentimes it will even like separate the columns automatically. If it doesn't, you do, I think in this case it didn't, and I went to split text to columns, just put the entire, like pasted the entire thing and then split text to columns, and then you get each column. So we have all this information in the CSV. I don't care about most of it. So I'm just gonna, for example, hide all these columns. These are just different ways of doing the same thing. Right? I'm gonna just hide all of this and basically extend the Volpiano column. So you see each of the entries that I have, all of these are Volpiano strings, right? That I want to maybe obtain and parse and do operations with in my code. Just for fun, nothing really important that we're doing with them. So one way that you can operate with them in Python, there's a standard module called CSV, which is the one here. By the way, import means that you're importing a package, a module in Python or a package. And a module is just basically a Python source code file, right? That's one way that you can think of it. And some of them are already available to you. This is CSV is one of them. It's part of the standard modules that you can import in Python. Here's the documentation. You can find in the docs.python.org. You go to the specific Python version and you see the CSV module. The source code is available, you can see it, but specifically we are going to use a function or a class called dict reader. Dict stands for dictionary, which is a hash map, or also known as a hash map in C++, or yeah, just basically a key value data structure that is very popular in Python code. So that's what I'm importing, CSV. And from the CSV, I'm importing the dict reader object. And I downloaded a copy of the CSV locally. So I have it here. This is the same one that I've been showing you. In fact, this is much better, nicer than the syntax of the Google spreadsheet. So I didn't know that. I just found out. And when if you want to know how to operate with this, with the output of the dict reader, you go and read the documentation. But generally, I'm just giving you a summary here. You get an object, dict reader, and that object is something that you can iterate, and it will give you each row of the CSV. So for example, and it's in a dictionary format. So if I print, let me print the first row and then break just stops the loop. So after the first row, it will stop, right? And if I do that, you will see that I have Siglum, And that's the key. You see the column, that means that it's the key, and this is the value. And the value is a string with the value of the signum. Then marginalia, and has nothing, so it's an empty string. Folio, and it has a value, and so on. I really just care about the column Volpiano. So for this row, if I wanted to, for example, access the Volpiano, I do this, and this is Python syntax for accessing a specific key in a dictionary. And if I do that, then I will get the string of the Volpiano. So I could potentially remove this break. I will go through every row in the CSV and print the Volpiano. Something that I noticed when I did that is that you see some blank entries in here. What that means is that that specific row in the CSV did not have a Volpiano, which is a valid thing to happen. Like maybe there is an entry that doesn't have any music encoded. That happens. So you will see all of those as blank lines that don't have anything. And I don't really want to include those as part of my function, right? So I want to filter them in some way. And the easiest way to do is, and I will probably refer you to the idiomatic Python post that I shared before. Basically in Python, everything that is an iterable that doesn't have anything in it is considered, or its truth value is false. So for example, if I'm trying to do, let me add something here, an empty list. So if I try to turn this Boolean empty list into a value, it will get false. But if it has an element, whatever element it has, this is a list on an array or an array, then it will be true. And the same thing is true for dictionaries, tuples, or any other data structures in Python. And it's also true for strings. So if I have an empty string, that's gonna, its truth value, it's gonna be false. But if it has anything in it, it's gonna be true. So I can do that, operate with that nicely in Python and say that if row Volpiano, and in this case will be, the meaning of that will be if the column Volpiano of this row is not an empty string, then print the row Volpiano. And I can remove this. And now I will have only the ones that have any value, any string. Does that make sense? Cool. So that's basically what we are going to do for the implementation of the function. The last piece of the puzzle is that I requested that it should have max length optional value, so that if, for example, I only want Volpiano strings that are at maximum 20 characters long, that should be possible. And the way that you will do that is, for example, doing if maybe at this point you can see how patterns start to emerge. So I'm using row Volpiano and then row Volpiano again. So maybe at this point I will want to define Volpiano as a variable and have row Volpiano. And that will basically turn the string that I have in this column into this variable. So now I can check Volpiano, and length of Volpiano less or equal than my max length. I haven't defined what the max length means. Then I can print it. And basically I will set it here for the time being as, because I'm just sketching, right? This is not the function. You will see the function in a second. And it's going to be 20 characters, let's say. So now if I run this, theoretically, I should only get strings that are 20 characters tops, right? And that's basically the logic of your function, or one possible implementation of the function. Let me show you what it looks like when I implemented it. So I have my Volpiano file. The function is called obtain. Something that I did change from the approach that I showed you is I don't want to download the CSV and have it locally on my repository. So I'm just gonna download it on the fly. So instead of assuming that I will have a CSV file on my repo, I have a URL as a string, and I'm going to download the CSV file on the fly and operate with it and just return the strings, the Volpiano strings. So that's defined in a variable. I just call it Paris 15181. This is like a global variable. You can think of it as a global variable. And I have a function which by default, I can specify the CSV source. So this could be a URL. And by default, it just defaults into this one that I already have defined. So it's, if nothing else, it's going to operate with the one that it knows that it exists. So that's how it's going to be defined. And my maximum length, let's say it's 10,000 by default. So the user can define that. This is the doc string. It does not much other than describing the general functionality or description, like English, natural language description of your function. So the convention is usually to have a one sentence summary, then you have a longer explanation later. But you can see the PEP, the link that I put to the PEP 257, which specifies how doc strings should be implemented. But the general rule is just that, what I mentioned, and that it goes right after the definition of a function or a class or whatever you are documenting. So in this case, it just says get a list of Volpiano strings, and a longer description says fetch a CSV from the Cantus database and extract the first max length Volpiano strings from it. So for this, I'm going to need a couple of libraries. All of them are standard. So what I mean with standard is that those libraries will be available to you as soon as you have Python. So for example, if I have, let me do pip freeze here, and that will show you the packages that I have in my virtual environment so far. I think the only thing that I installed was the black formatter. So that's why I have a few things installed, just dependencies of the black formatter, but you don't see anything like CSV or URL lib or the other ones, and that's because they are standard. They're just part of Python. Okay, so for example, let me trigger my my interpreter, and I'm just gonna do import CSV, and that's going to work. But if I do import TensorFlow, which is not standard library, it's gonna say no module named TensorFlow. I need to install it. It's an external module. Does that make sense? So we're working with standard libraries, all of these. Okay, so basically they don't even need to go into they will not go into the requirements.txt, but because they are already available. So yeah, I'm going to use one function from the URL lib.request library. Again, this is something that you can see on the documentation. This is for unit. I didn't have I didn't leave this one at hand, but you can find it. It's on the documentation. And what it does is just basically does an HTTP request to URL. So my URL is here, or actually comes as a parameter to the function. I open it. Read just basically means that it takes the contents of that, because the URL, when you open it, of course, it's a request. So it will have a response. It will have like a header and other things. And basically what I want is the content, right? When I do a HTTP request on this CSV file, the contents will be the CSV lines themselves. So that's what I do with read, but that's going to be read in a byte format. So it's going to be read as bytes, not as text. So for that, I just do the code as UTF-8. So that's what this portion of code is doing. Once I have that, I know that I have contents. In my contents is a variable that has text, and that text has all the CSV. And I put a comment here because basically the next part, the next logical step is to put this context contents into the dict reader, the dictionary reader of the CSV, and just collect the rows of the CSV. However, the dictionary reader only works with files. It doesn't work with strings. So I need to give it a file, and then it will operate over the file and give me the rows. But if I give it the string with the CSV, it won't work. So for this, I need some like hack, let's say, where I'm going to create a fake file. And that's what the purpose of this string IO. And I put a comment here that says the dict reader only reads files, not strings. As a general rule, and I take this from Chiro because he repeats that a lot, and I agree with that mindset, my comments are only whys. Like, why do I do something in my code? Not like explaining things that should be self-explanatory in the code, but the reason why you do something. So if someone is reading this code and doesn't know what I just said about the strings in the CSV file, will see, okay, why didn't you just put the contents in here? Like, it makes sense. And they will find out that maybe it won't work, or it will like give them garbage values when they try to extract the rows. So they need to know that the reason why you need this fake file in between is because the dictionary reader of CSV doesn't work with strings. So you have to create this like artificial file. And so I do that. I just called it contents F, dictionary reader. And now I have a dictionary of the CSV rows, which is similar to what I was showing you here in the Jupyter notebook. Basically equivalent to reading the local file. And now I can iterate over each row, which is exactly what I'm doing. So for row in the dictionary, I create a variable called v. This maybe not, it's not the best name. Maybe we want to call it Volpiano. I don't know. So that's all up to discussion. But the important thing is that the string in that column becomes this variable. And I just check if b, and if you remember what that meant was basically, I want a string that has anything except for an empty string, okay? I don't want empty strings. So this is the first check that I do. And then I just validate that the length or the number of characters in this string, it's less or equal than the max length that I defined as a parameter. And after that, I just append it to the Volpianos list, and that Volpianos list is going to be what I return. So that's the implementation. Now, how to write the unit test for that and make sure that it works. So what I did in advance was I basically made that same query that I showed here, which is for 20 characters long, all the ones that I could obtain. And I think I got 49 Volpiano strings. So that becomes my list of, let's say, ground truth. And I follow this convention whenever I write code, I call this the ground truth. So I know that for the moment when I was writing this code, this was the values that were returned when I query it for 20 characters long. So I just make them a list. And basically what I'm going to do is when I run the unit test, I'm going to call the function with maximum length of 20. That will give me a list of Volpiano strings. And I'm going to verify that those are the same values that I have in my ground truth. If they are not the same, then the unit test is going to fail, okay? And think about when will that happen? Well, it will happen when the information changes in Cantus database, for example. If they add a new Volpiano, then my unit test is going to fail. If I change the implementation of my function, and then let's say that I had a mistake here, and instead of less or equal than, I had just less than, that will also fail, or other circumstances. So that's why it's useful to have it. And basically, with this unit test, I'm basically recording the current behavior of the function when I implemented it. If everything goes well, I did a very thorough check that all of it, maybe checking the 49 results by hand, just making sure that those are the 49 volt piano strings in that CSV as of now in Cantus DB. And then I write the unit test and it will run. So by the way, all unit tests by default will pass. So pass is just a keyword in Python that does nothing. It's just a keyword that you use as a placeholder. So for example, there's no implementation for this unit test. I'm doing no unit test there. And by default, that means that they're going to pass, okay? And this one is not going to pass automatically. It has, and they all have the same convention, assert something. And you can read more about unit test operations here. So let's go to assert equal. Yeah, so you will see assert not equal, assert true, assert false, assert is not, etc. And all of these are the operations that you can check for when writing a unit test. So I'm just checking that the list is equal to the one I have in ground truth. Do you notice anything weird in here? Like suspicious? What happens if I just do this? Would that work?
But we are not passing those variables to the class, sorry, to the method. So would that even work if we pass them as parameters?
What do you mean that we are not passing them to the class?
Like the method only has self, right? We aren't passing anything to the method. So isn't volpiano and Optane GT like universal variables? Oh, sorry, I guess volpiano is not, but Optane GT is.
See, yeah, so Optane GT is something that I fixed into my unit test. And Volpianos will always, so if you see the call here, it says volpiano.obtain. And if you go here, it imports Volpiano. That's the script. So I'm always getting those, like all the process of going through the URL, making the HTTP request and so on, it's going to be done every time that I run this code here. So these are the ones that we're checking, and this is the ground truth. And yeah, so the question was more around why do it, because this, if I do set, I turn them into a mathematical set. And the reason why I do that is because maybe when I do the HTTP request, maybe I get them in a different order. I don't know exactly if that's going to happen, or if the CSV, is going to arrange the values in different order. And for me, the important thing is just that I get the same set of strings. So the order doesn't matter. And yeah, so that's why I did the set. In theory, it should work without set. I just decided to not care about the order. And that's the reason why I did that. So that's basically the implementation of this first function. If I do Python and unit test, it will run the tests. And it says it ran 3 tests. It took 0.2 seconds, and they're all okay. Let's see it failing. So I'm going to just modify one of these values. I'm going to remove a hyphen from one of these, save it, and then run it again. And it failed. And you get a message from the unit test. It says which test is failing. I know that it's test volpiano obtain. And inside the test volpiano class, so this one, and it says that items in the second set, but not the first one. And yeah, so basically it's telling me that this, and maybe this is a cryptic error message. So you have to play around with different methods of unit test to see which one provides you with the most useful feedback. But generally, just means that it couldn't find this value, this string, in the ones that it obtained from the function. But that's useful for me because I know that something is not working or I need to pay attention to it. And basically, in this case, I know that I introduced the bug myself, and it was just testing that the testing was doing something, and it does. So that's the first implementation. What I'm going to do now is just basically go, so I'm on the Optane, so I'm going to go to main and merge the Optane and push. So if you go to the repo, where is it? Yeah, here in the main branch, you will have the source code that has up to the Optane function. So now let's move into the validate one. So validate, and I have a branch already that has a code. So let me check out and validate. And I change the branch, it changes the contents of my files. That's why branches are very convenient. So if I go to Volpiano, I have all the implementation of Optane that I wrote the unit test for, all the like the URL that it required, and now I have validate as well. Here's the doc string for validate, return true if Volpiano is a valid Volpiano string, and the comparison is done on whether all characters in the string are valid Volpiano characters. So when I did this, I actually found that it was too lame of an implementation because some really obvious files were passing as valid just because they had the same characters as a Volpiano string. And so I added this extra check at the beginning. First of all, let me show you how do you know that what's the vocabulary or the allowed characters in Volpiano. I found two documents. One of them is in Cantus Waterloo, so the Cantus database, and it says Volpiano protocols with self-test. And it has like some basic operations and syntax of the Volpiano. So you see how you encode, for example, different nodes, accidentals, a liquescent num that I read the wiki entry, but I still don't understand. And there are some other things related to how it works and the relationship between hyphens and lyrics and notes. So I didn't know this. Yesterday I was talking about Cantus Ultimus and the Volpiano. I didn't know that there's a meaning to the number of hyphens, and that is relating the notes or the nums to the lyrics. Okay, so that's something that I learned for this exercise, and so on. But it doesn't really have the like dictionary of notes or of values. But I found this in the official repository or not repository website of the Volpiano font. And what I did is just basically copy all of these characters and say whenever the string has a character that is not included in this Volpiano Basisschrift, then it's not valid Volpiano, plus the additional check of the initial portion of the string, which is just basically checking for the clef. So when you start the Volpiano string, you need to have a clef, and the clef symbols are either 1 for treble clef or 2 for a bass clef, and it must be followed by 3 hyphens for non-transposing treble clef. So what I did is just, it has to start with either 1 dash 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 or 2 dash dash dash, okay? And that's what my implementation looks like. So if not Volpiano starts with this and not starts with this, then I know that it's not valid. And after I pass that, then I also check, and this is a bit like hacky, but it's a regular expression. So regular expressions are a bit above or beyond the scope of this tutorial, but basically you can think of this regular expression as making sure that these characters, just finding any of these characters in the string, and for each of them, like if it finds them, then it will sub is a function that substitutes. So think of this as a string replace. You have use the string replace, I assume. So let's say that I want to find the word banana and I want to replace it with apple. So I will do something in a text editor like this one. I will do search for, let's look for a real word like reads, and I want to replace it with writes. So you will run that and then replace the string occurrence, right? That's a typical thing that you will do with the text editor. So you can do the same with the regular expression. So instead of finding just the text string, you find something a bit more complicated. And in this case, what I'm looking for with the regular expressions is a character. Just this is a list of characters. So characters from 1 to 9, or A to S, or capital A to capital S, and so on. And the ones that you see here are escaped. So in opening square bracket, closing square bracket, or hyphen. And that's what I'm looking for. And if I find any of those, I'll replace them with nothing, with an empty string. And basically my check then is that I don't have an empty string. So if I have an empty string, that means all the characters are within the Volpiano dictionary. If I find at least one character, that one character is not part of these tokens. So I know that it's a not valid Volpiano string. Maybe it looks convoluted, but my motto is the least code possible, amount of code possible, and as long as it's sort of clear to read, then that's good. So I always push for that kind of compact coding. So my return is just a Boolean value, and if it looks convoluted, just think about returning the Boolean of this. That will be the same, but I like not better than Boolean. And yeah, that's the implementation. The test is just making sure that for every of the files of the strings that I found here, all of these should pass as valid Volpiano strings. And for this, I use something called the subtest. It's a fancy word for a for loop when you're doing tests, okay? Whatever you put here, you can define it. It's arbitrary. So this is helpful for when you want to know a specific place in the loop that is failing the test. So for example, let's say that, so first, let me run the unit tests and it should pass, right? And I know that it's validating all of the correct, like valid Volpiano strings. And maybe let's insert an invalid character here. For example, a star. I don't think a star is part of Volpiano. So what I should see is that my code in the unit test is expecting the string to be true when I validate it. But what should happen is that it throws as or it shows as invalid with my implementation, and that will fail the unit test. So yes, it failed. It says items in the second set, but not in the first. So it fails in two places, right? It fails in the Volpiano obtain because it couldn't find this when it went to Cantus TV, make the like HTTP request and abstracted the Volpiano strings. It didn't find this one, so that's one fail that it throws. And the other one is that it also failed the validation. This one was false according to my validation function, but I am saying in my unit test that it should be true. It should assert true. So those are checks that I can do like iteratively to make sure that my unit tests are catching the problems that I expect them to catch. And if that works, then maybe I'm happy with that implementation. I forgot the second part. The second part is just, I generated some fake ground truth Volpiano strings. They're all 20 characters long, and they have lots of hyphens, so maybe I can confuse someone, someone who doesn't know about Volpiano like me yesterday. But they're all invalid because they have different characters to the ones that are valid, and they don't start with the clef that they should. So each of these, when I pass them through my implementation of the validation function, should say false. And that's what I'm checking on my unit test. So yeah, so for example, if I turn one of these into a valid Volpiano string, which for example will be changing this U here, I think. Let's try that. No, that still passes as invalid. Yeah, I don't know how to make one of the fake ones into a true Volpiano string, but they should basically fail the test if they are valid Volpiano strings, essentially. So that's the second function implemented. I'm currently on the branch that has the implementation, so I'm going to move to main and merge the validate function and push. So now in the Git repository, GitHub, we should have, if I refresh, you have up to the implementation of the validate, okay? And it passes the unit tests. So the third one, and I'm going to go quickly so that we can see actions in action. Let me go to that branch. Same thing. I have the code. The comparison is going to be very simple. I'm going to use a library. There is a standard Python library called dflip. And there's an object there called sequence matcher, which, do I have it here? Yeah, like dflip sequence matcher. And sequence matcher specifically has something called ratio and returns a measure of the sequences similarity as a float in the range 0 to 1. It's misleading that it says sequences because actually strings are sequences. Okay, so it's a sequence of characters. So that's what I'm comparing, a sequence of characters versus another sequence of characters. And that's what I'm doing here. I'm just basically, if you look at the syntax, you have of sequence matcher. It's kind of, this documentation is not amazing for this particular module, but basically you require an A value or A sequence and B sequence. And that will return an object. I'm saving that object as with the name comp. And then I just return the ratio. And the ratio will be a number between 0 and 1. And 1 means perfect comparison, is the same string. 0 means absolutely nothing to do with the, like, not similar at all to the other string. And anything in between is partial similarity. And the rule of thumb is that anything above 0.6 is similar. Similar is string to the other one. So what I did for my unit test in this case is I have a list, and in this list, what I did is I compared the first ground truth of Volpiano, which is this one. I compared it to every other, okay? So for example, this and this, and the first one to the second to the third one, and so on until the end of the list. So, and I computed the scores for that. That's my ground truth. That's what I expect the function to retrieve once I run it. Of course, this is very fragile. All of of all three functions, this is the one that is most fragile in terms of whenever I change and I use a different metric instead of the sequence matcher ratio, it's going to throw completely different numbers, right? So that's kind of the things that you want to take into account when you're writing code, that your unit test could be very fragile depending on your implementation. So it's a matter of design more than anything else. So for this toy example, I don't really care, but maybe for a larger project, this is not a great unit test. But unless I can think of something better, then this is better than nothing. So in this case, I have all of the values. That is something that I call ground truth, obtain ground truth. I'm just shortening the name of the variable so that it fits within the 80 line limit. And what I'm going to do is use, if you don't know this syntax, this is called list comprehension. And this part of the things that you will read in the Python idiomatic Python. So it's basically a for loop done in a single line. And people in Python use it a lot. So it's actually quite easy to read once you have familiarity with this notation. And it's faster also to run it. So if you have a for loop and you implement it this way, it's generally going to be faster running, because of how Python reads line by line, and in this case, it knows exactly what to do in the single line. So if you had a for loop and you go like sequentially, it figures out what to do line by line. But in this case, in a single line, it knows everything that it needs to do during the loop, and that can be useful for optimizing the code. So in fact, they are faster than doing a for loop. Okay. And well, basically what I'm doing in the for loop is I run the comparison function between index 0, which is the first value of the first string in my ground truth, to any of other string. And that the way I write that is just starting from index 1. Remember that Python starts counting from 0, like C-based languages and Java and others. So 0 will be the first element in a list, and 1 is the second element in the list. And this notation, the colon here, just means until the end. So from the second element until the end, I'm going to compare the first element versus that ith element. And whatever score I retrieve from that, I'm going to store it as a list of scores. And that list of scores should be identical to this list of scores. Does that make sense? Okay, so that's the unit test. And if I run it.
Why do you use almost equal?
Good
Because
question.
of rounding, potential rounding error with the score calculation.
Yes, because this is all floats. And
okay, yeah, okay, then you'd have to use almost equal, right?
Yeah, and there's a special parameter about almost equal. Let's go to unit test. Where is it? Almost equal, where you can set the rounding. By default, is set to 7 figures, but you can maybe make it. This is actually a lot, I think. So you could make it 2 or like 3 decimal values. And yeah, that's the reason. Whenever you work with floats, it's not recommended to do direct comparison of numbers. So you always want to have like small range of values that are acceptable, like a small delta that it's acceptable as the same value. And yeah, so the unit test does that for you, or has some assert function that does that for you. Yes, so I think this function is actually quite short, and I don't know if there are any questions about the functions themselves or the process of the unit test. Anything that you want to ask about that? We can revise or have like discussion about this. The code is going to be available public and so on. So I'll just merge for now. Merge, compare, and push. You can see the version history there as well in the repository. So 5 commits, and it's nice to see. I'm very happy with how GitHub starts like formatting all of this for you. So you can see the exact changes from one commit to another. And that's very useful when you're looking into a project and how it has changed over the time. So it's great. So last thing is I'm running all of these unit tests manually in my computer, then I push. And that requires a lot of discipline, right? Because you're coding, and I've been like kind of thorough in making a test that fails, and then just pushing once I know that it works. So what can you do about that? This is the where actions comes into place. And actions is just basically something that people refer to as continuous integration. That's the general jargon in computer science. Before actions was available, because it's pretty recent in GitHub, people used to use Travis CI, which also lets you do this automated tests for free. It's just an external service. It has nothing to do with GitHub. And yeah, so still useful. People still use Travis CI. That's pretty much the same thing, except that GitHub now has this like in-house service called Actions. And the way that Actions work is it's you can look at the documentation. It's convoluted because, of course, this works for multiple languages, and people can do all sorts of operations at their push or commits or anything operations on their repositories. So you can read a lot about how it works. But essentially, if we resume it to like summarize it to the 10 minutes that we have left, it's essentially a YAML file. Alex was talking about YAML files in the morning. So let me show you how that looks. So basically, you just need a folder in your repo called .github. And inside that folder, there's another one called workflows. And inside that, you have a YAML file, which in this case, I'm going to call main.yaml. And inside that YAML file, I'm just going to paste my GitHub actions that I already did. So you have when is this action going to be run? And I say it's going to be run on when I push to the main branch, or when I receive a pull request to the main branch. That's it. That's what it entails. Then it has all the jobs that I'm going to run. And here you have to refer to the specific commands that are available or actions that are available. It's a community, so people submit their own actions all the time. You can lint automatically, you can format automatically. In this case, we're just going to run unit tests automatically, and that's going to happen in this one. So each of the hyphens starts an action. And when it says uses, that means that I'm using an external action from the community. And in this case, it's called checkout v2, version 2. And that's one of the ones in that people use for basically fetching the, it's like cloning your repository, essentially. And then set up Python. It's just having your Python interpreter with different, here's where you will put, for example, 3.9 or 3.6, 7, and 8. And that means that it's going to run the unit tests and all your actions in different environments of Python. In this case, I'm just going to run in 3.8, okay? Then it installs some dependencies, and it's going to install them in your, it's going to install the Flake 8, which is my linter. So it's going to make sure that it's going to do some static analysis of my code. And whenever I pass the 80 column limit of my lines, or I do something funny with my code that that PEP8 doesn't like, I'm going to get an error from that. And at that point, my action is going to send an email and notify me that it's failing for that reason, for Flake 8 validation. So that's this one. This is just installing it. And it's going to install whatever I have in my requirements file, if I have a requirements file. We haven't added the requirements file. I'm going to add it at the end. And the last one, so this is the actual linting with Max, with Flake 8. These are the parameters. This is I took this from a template. So this is just, I think, a template that I found in the community of people, how they recommend you to run Flake 8 to validate your source. Okay, so we'll have to look at the documentation of FLEC 8 to know exactly what these parameters mean, but generally that's something that people have contributed to the as a template. And the last thing, which I really, it's what I care about, it's running Python, the model unit test. -b stands for verbose. Maybe I don't even need that. I'm just getting more feedback when there's an error. And that's it. Like if this passes, it's gonna pass the actions validation. If it doesn't, then it's gonna send me an email and it's gonna appear in the build as this build is not passing. So if I submit that, technically I should see that file there. I see the github.github folder, and I'm gonna add it and commit actions YAML file. So let's see if that works. I think I haven't done it this way ever. So let's see. I hope that it will work. So I know that it has the GitHub workflows and it's there. So now let's see if it trigger any action. Oh, complaints. Failure. This work cannot be shown. Yeah, in fact, it's the first time that I do it this way. So I don't know why it's complaining. Let me add a new workflow. Python application. Maybe the syntax change, I don't know, because those things can happen. GitHub workflows main. But yeah, I think the syntax of this change maybe, and that's why it's complaining about it. So let's do Python and unit test. And I'm going to submit one of their templates instead of my own and see if that will do. So let me remove this one. And let's see. So this is something that is, yeah, now you see that it's actually running. So you see that, unfortunately, these tools, I think they implemented actions in 2020, and this is constantly changing. So the syntax of the YAML file and the actions are going to change. I had this because I used it in a different project and I thought that it would work the same way, but apparently it doesn't. So now I need to make sure that the actions YAML file it's working. So it says it passed. Let me go to the details. And here you see the summary. So you see the operating system, actions, setting up Python 3.9. So it's testing on 3.9 instead of 3.8. Technically, I should be able to add more Python environments and it should run on all of them. The linting on FLEC 8 is passing, and the PyTest, the unit test is working. So yeah, this name is misleading, this description, but it's actually running unit test and it passed all the tests. And then it did some cleanup and completed the job. So what is this useful for? Let's say that I changed the implementation of one of my functions and I submit the code, I push it to the repo. It's going to run this and check the unit test for me automatically. If it doesn't work, then it's gonna show like a fail here and it's gonna send the email. And that's great. That's very convenient. If someone makes a pull request to this issue, to this repo, and they do that pull request to the main branch, it will also run all of this automatically and make sure that I know beforehand if it passes all the tests. And that's going to be done. And the linting as well, the FLEC 8 linting. Yeah, so I think I ran out of time. Last thing that I didn't cover was because we had to shorten the tutorial from the original allotted time is that semantic versioning. But semantic versioning, which is just how you name a repository version, is something that you can read here. And it basically summarizes everything about this topic very well.